remembering is never taken for granted anymore. You'll see here at the top, this is just a little review of what we were doing the last couple of days of last week. And we have our little trick here, the little phrase, where it says, sine is opposite hypotenuse, cosine adjacent hypotenuse, tangent is opposite adjacent, and then we can just simplify all that into the little phrase of SOHCAHTOA. And we're going to continue with this theme pretty much this whole week. My guess, as I looked at things, we'll probably quiz hopefully on Friday. So I hope what we're going to be doing here, we're going to do some of these today. We're going to have some word problems over the next few days, and hopefully we'll be doing our quiz on Friday of this week. So real quick review. If I ask you for the sine of angle A, that simply means if I look at angle A right here, the sine in the SOHCAHTOA idea is this S, and it's telling us you're going to look at the opposite side and put it over your hypotenuse. So if this is angle A, the opposite side would be 15, and the hypotenuse should be 17. So the sine of angle A, we would say, is 15 over 17. If your trig functions are ratios, they're fractions. All right. When we then go to the tangent of angle A, similar. In the fact that you're looking at angle A, the tangent is the T in our little SOHCAHTOA phrase, and then that's telling us that we want to do the opposite over the adjacent. So if this is angle A, the opposite side is still going to be 15. The adjacent side that is not your hypotenuse is right here. That's the 8. So the tangent of angle A should be 15 over 8. And then the last one, we switch our angle. So now we're going to be looking at angle B. Or looking from angle B is probably a better way to say it. So now I'm here. Cosine is this part of it. That's the adjacent side. The adjacent side that's not your hypotenuse is 15. And that's our A. And then over the hypotenuse, which is 17. So that should be 15 over 17. There we go. And then that's our cosine of B. When we did these the other day, notice how the sine of one angle should always end up equaling the cosine of that other angle. All right, that's not a coincidence. It's one of the little things that we proved the other day when we were doing some of those little properties. All right, so kind of recall that. That's a review. Even what we're going to do now is going to be a review, except we're going to add a layer to this. So let's say I now gave you this right triangle, and I ask you to figure out these sides. So if I ask you to figure out what x is right now, our old Pythagorean theorem isn't going to work, because notice how we don't have that other length. If I knew that this length, let's say this wasn't a variable, and this was, let's say, 25, I could do the Pythagorean theorem, because I know 2 of the 3, and then we use the Pythagorean theorem to get the third. Well, what happens if I have a right triangle, and all I have is one length? We can't do the Pythagorean theorem. We would need one more side. So the way that we can set this up, first, we're going to find the variable x, and then we're going to find y. So what we're going to do, look at this angle here for angle A. Notice how I know angle A. I want to find angle x, and I know that. So of the 3 things, the angle and the 2 sides, do we agree we know 2 of the 3 things? Yeah. So whether that's the Pythagorean theorem, or if we're now going to be using these SOHCAHTOA ideas, we still have to know 2 of the 3 in order for us to solve for that unknown third part. So go to angle A. Notice how, if I'm going to use 42 and then the x and the 12, if this is angle A, isn't x the opposite side? And isn't 12 your adjacent side? So if angle A, the variable that I'm trying to solve for is the opposite, and the side that I know is the adjacent, opposite adjacent is telling us that we want to deal with the tangent, the TOA part, SOHCAHTOA. Instead of having to do this, so don't write down what I'm going to write down right now. So instead of doing the tangent of angle A equals x over 12, right, because this is the opposite side over the 12, this is what we've been doing. Don't we now actually know what the degree measure of angle A is? We don't have to use the variable anymore. We know that the degree measure of angle A now is this 42 degrees. So instead of the generic variable a, you're going to actually plug in here, write in here, 42. So the tangent of angle 42 is the opposite side of x over the adjacent side of 12. If I now tell you to solve that equation, now it's just some basic algebra from back in the day. If I want to get x by itself, we want to undo this division, right? We're dividing by 12, so we undo division through multiplication, so that's going to cancel. And then we know whatever we do to one side, we've got to do to the other. So I'm going to have to multiply the other side by 12 as well. Here's where if you don't have a calculator, you're going to be in big, big trouble if we don't have one of these when we sit down to take this quiz, because the only way you're going to be able to do this is throwing this now into your calculator. So in your calculator, so let me pull mine up. This is the easy one. You're going to just do 12. And then notice what I'm just plugging in here. 12 times the tangent of 42. You can hit the times if you want to. It's not necessary. The calculator knows if you put a number next to the tangent of 42, that it's a multiplication operation. Hit enter. Let me make sure I'm in degrees because calc we've got to be in. Yeah, so we should be good. So that should be your answer. All right, do we all get 10.0? Yeah. All right, look at your directions now. Did I tell you? Here it is. We will round our answer to the nearest hundredths. So the first decimal is your tenths. Your second decimal is your hundredths. So we are rounding to the second decimal place, which in this case, I guess, we'll put the 0. You don't necessarily have to put the 0 if that was what we would round to, but that should be the length of x. So now x should be 10.80. Yes, good. Now, the next one, we're going to find y. Now we have a number of options, because now don't we know 2 of the 3 sides? Yeah, so you could if you want. I'm not going to in this one because I want to make sure we understand the new way, but couldn't we now do the Pythagorean theorem? Do an a squared plus b squared equals c squared. That's now going to work. So that is a perfectly legitimate option. Okay, there's nothing wrong with that. So actually, let me just put that as one of our options. But just to make sure we have other options and understand how we can set up these other options. Other options now, we still have 2 more other options. Let's start with what we were given. So what we were given is, again, angle A is 42 degrees. And we knew angle 12. Well, if I know 42 degrees this angle, this is 12, and I now want y, think about how 12 and y relate to this angle here. Isn't 12 the adjacent side? And isn't y your hypotenuse? So think about adjacent over hypotenuse. So if we go to our SOHCAHTOA phrase up here, this dumb thing will stop spinning. Notice what adjacent over hypotenuse is. Again, here we adjacent over hypotenuse. Isn't that your cosine function, the adjacent and the hypotenuse? So if we base it on the ones that you were given from the beginning, we could have said that the cosine, and we could have done this right away. We could have solved for y first. The cosine of that angle would have to be the adjacent side over the hypotenuse. And I want to do it, this one I want to see through. I'm going to assume step 1 here, or option 1 with the Pythagorean theorem, we could figure that one out on our own. This one, if I now tell you to solve this, first of all, do we understand where this comes from? If we never want our variable in our denominator, so we're going to multiply that out of there. So it's going to cancel here, and then you would end up multiplying y to the other side. So what our equation now looks like, it looks weird, is this. And if I now tell you to solve for y, if I want to get this y by itself, can't we undo multiplication with division? So let me clean this up a little bit. So if I divided by that cosine of 42, and this is how you're now going to plug this into your calculator. So divide by the cosine of 42, it obviously cancels this one out. On the other side, here's how we would now need to plug this in. That y equals 12 divided by the cosine of 42. So on my calculator, I'm going to use the fraction key. You don't necessarily have to. So again, if you have the alpha y equals version of this, it's going to pull up the fraction nicely, and then it's hard to mess that up. You just make it look like what I have on my paper or what you have in your paper. And that was, I probably need to know what it was, 12 over cosine of 42. If you have an older brothers or sisters calculator that's been in use for a while, you don't have that, you can just do 12, hit the division key, and then do the cosine of 42, and you'll see that it'll give you the exact same answer. All right, the 16 point, then we're going to round it to the 100th, 16.15. Same thing we would have gotten if you had done the Pythagorean theorem. Now, there is a third way, because now don't we know the other triangle, or the other side? This one we're not going to see through, but if I were to use this angle, don't I also now know the opposite and the adjacent? So I could have done the tangent of 42, because I knew the opposite was now 10.8, and I could have divided it by that adjacent side of 12. All three of these are going to give you the 16.15. So once you get one of them, it's really sort of up to you how you're going to proceed with the next one. Because you're going to see here in a second, when you're told to solve a right triangle, you just have to get all those values, and whichever method you're going to use is going to be fine. All right, now the tricky one, the one that we want to be really, really careful of. So it says to find the missing angles of a triangle. So now notice we have all the sides. Let's do A, just because A comes first alphabetically. Let me do it this way. So I'm going to put so. I'm going to write these vertically. Ka, toa. Let me do colons here. Because really there's all kinds of different ways to get this guy going. If I want angle A, Vicky, what do you like best, Vicky? Sines, cosines, or tangents? I know they're equally fun and enjoyable. Sine. All right, so Vicky likes the sine the best. So if we're going to do sine, then I'm going to do the sine. Come on, you. There we go. The sine of angle A. Notice how we now don't have this. Like we don't know the degree measure of this one, so we have to use the generic variable. And since Vicky likes the sine of angle A, the sine is the opposite over the hypotenuse. So for angle A, the opposite side is 9. The hypotenuse is 41. You don't know how to solve that yet. We're going to do that in a moment. So Jenna, of cosines and tangents, which of those two do you like the best? All right, so Jenna would like to do a tangent. So let's say we wanted to do this. If you like tangent the best, couldn't we have said the tangent of this angle should be the opposite side over the adjacent side? So if we do tangent, the opposite side is the 9. The adjacent side is the 40. I guarantee you both of those will give you the same exact answer once we learn how to solve them. And then since there's only cosine left, we don't like the cosine apparently, isn't the cosine the adjacent side? So that's going to be 40 over the hypotenuse, which is 41. You could set up any one of these three options, and when we show you how to solve it here in a second, all three of them are going to give you the exact same answer. All right, so it's really up to you. There isn't one that's better than the other. All three of them would work in this instance. So here's how we're going to do this one. So let's take this guy here. So I'm going to do the sine of angle A is equal to 9 over 41. What this is based off of, don't write down what I'm going to write right now. Let's say I gave you 2A equals 40. When we solve that equation, so you've been doing this probably since like 6th grade, don't we want to isolate this A? Come on. And we need to get rid of that too. So if I want A by itself, we need to get rid of the 2. The way we would get rid of the 2 is by dividing by 2. And then these would cancel. My dumb thing is not changing. There it is. And then wouldn't A equal a 20? So we want to isolate our variable. So we want to get rid of, if I want to get the A by itself, don't we need to get rid of this weird word, 3 variable letter here, sign? We need to get rid of that. Well, you can't divide by a sign. All right, so get that out of your head. We can't come over here and say I'm going to divide this by a sign. The way that we get rid of a sign is with this little guy right here. So look on your calculator, and I'll show it here in a second. Look at the sine key, the regular sine key that you probably have already used. Look above that. So it's not a key, it's written on the calculator wall itself. See how it says the little sign of a -1? So the way we get rid of that, and the way that is read, is that's the inverse sign. It's going to freeze up on me, it would appear. So find that key. So I'll show you this since the word is frozen on me right now. So here is the sine key, and right above this is the second sign. That's how we get rid of a regular sign. So what we're really doing here, come on. I almost said a really bad word, not bad. I don't understand. The problem is when I record, it just doesn't like the recording isn't.
Recording plus the calculator.
And the calculator seems to use up a lot of bandwidth as well. And why does it jump to module 7 like 50 pages later? All right, we're getting there, slowly but surely. All right, this should be the next page. All right, cross our fingers. So what we want to do, and you can think multiplication, it's not multiplication, but if I take the sine of this side, what was that? What was that fraction? Sine of A equaled what? 9/41, is that what it was?
Yeah.
All right. So what we want to do is, to get rid of that, you're going to do the inverse sign of both sides. You don't really have to show that on the left-hand side, but what that definitely means on the right-hand side, you now need to do the inverse sign of 9/41. So the only way you're going to get this inverse sign is going to your calculator, and it's the second function on your calculator. So if I hit second sign, notice how the little weird inverse thing is now there, the little -1 power. And then you're just typing in 9 divided by 41. Hit enter. See how that gives you, do we all get 12.68?
Yeah.
All right, so that then gives us what that angle degree measure is. So that is the measure of angle A. So A equals 12.68. Since I'm afraid to move this, what did I tell you to round to? Anything? What does it say? No. All right, for this question then, for right now, make this a nice whole number. So go to 13 degrees, since I didn't specify, and then you'll see why I want you to round it to a nice number. Fill that angle in now. So go to your picture, since my picture, who the hell knows where it's at. Fill in that angle as 13 degrees. Can't we then very quickly find that third angle with something that we started this whole geometry unit with at the very beginning of all of this? If I know one angle is 13, I know the other angle is a 90-degree angle. Can't we find the third angle very quickly with the 180 idea? All right, so then you don't have to worry about any trig. We just go through. That's why I said let's do 13 right now, just so it's a nice, easy whole number. I think it's coming up. And then that should give us our third angle. So once we know this is no longer a question mark, this is 13 degrees. Then if this is 13, this is 90. What is 90 minus 77? Yeah, 77. Angle B has to be 77 degrees. Real quick, just to prove this, just to show this, let's now take this one and as a little review to make sure we know how to plug these in, just confirm that this is going to give us the exact same answer. So if I want to solve this for A, the way I get rid of a cosine is with the second cosine on the calculator. So now real quick, plug this into your calculator. Plug in the inverse cosine of 40/41, and it better give us that 13-degree angle again, 12 point whatever it was. All right, so do that. And is it the exact same answer? Yeah. you don't necessarily need to do it, but if I were to take this one, if I did angle A, we could also do is the inverse tangent of 9/40. All three of those solve for the exact same value. Okay? So as we're going through these, if I set it up a little bit differently, you can see why. You just may be using a sine when I'm using a tangent, vice versa. It doesn't necessarily mean you're wrong. All right, so now let's go to these, and then we'll kind of knock some of these out. Any method is fine. So when I give you number one, don't overthink this. If you look at number one, we want to find all the missing information. So what that basically means is we need this side here, and we need this side here, and we need this angle. So we want all three sides, all three angles. Find angle A. Don't make this hard. So right now what we think angle A is. What was that? Who is that? Cam? What do you got, Cam?
39.
Good. And how'd you do that?
I had it 51 and then 90 degrees. Check that for 180.
Good. We could do the fancy trick stuff. We could do some sines, cosines, and tangents. Totally going to work. But if we can just do the 180 minus this 90 minus this 51, we know that's a 39-degree angle. The sides, however, now we can't do the Pythagorean theorem because we only know one of the sides. So what I want you to do, let's see where we are at this point. The only way we can do this to figure out either side AC or side AB is setting up one of your trig functions. So see if you can set up there's so many options right here that I want to see if you can set one up that's going to work. We know angle A, we know angle B, so you could use either one of those. And then you really could use pretty much any sine, cosine, or tangent depending on which angle and value you're solving for. So see if you can set one up that's going to work. And then if you just want to wait, I'll solve it, and then you solve yours and see if you get the same thing. All right, let's see where we're at. Here's how I'm going to set mine up. Yours doesn't look just like this. It could very well be okay. We'll just see if you get the same thing that I get. I am going to use angle B. So I am going to use angle B, and I know angle B is 51 degrees. I am going to find this side here. So I'm going to look for this side over here. I know angle B. The other, again, we always need two of the three pieces of information. So I know the angle and I know this side. So if I'm going to figure out this missing side over here, then angle B, this is the opposite side of angle B. This is our hypotenuse. So opposite hypotenuse, opposite hypotenuse. That is the sine, right? So of the SOHCAHTOA, opposite hypotenuse. So I am going to set up the sine of 51 degrees would have to equal the opposite side, I'll call this x, over the hypotenuse of 24. To solve this, I just need to get this x by itself. So whatever algebra needs to be done to do that, we then execute that. In this case, that would just mean we want to multiply by 24. So on the other side, multiply by 24. So whatever setup you had, what I'm now plugging into my calculator is this. 24 multiplied by the sine of 51 degrees. You guys might be quicker than me versus pulling, and I'm scared to hit the calculator. All right, Ella, you wrote something down. What did that tell you? Oh, okay. There it is. We confirming that? Okay, maybe I will plug it. Let me make sure. We all plugged in the same thing? 24 times the sine of 51?
Yeah, I got it.
So that, just plugging this in gives us for sure the 18 point whatever. Give it to me one more time. 18 what?
0.65.
All right. So then this should be 18.65. I did tell you to go to the nearest tenth. So that's our second decimal place. Did anybody else solve for this side and get something different? Did you try to solve for that side or was the other side? Okay, good. Anybody else solve for this other side and set it up differently? We're good. All right, then if I go to the other side, again, a lot of options here. So let me clear this up. If you now want that other side, totally up to you. The old idea is, can't we now do the Pythagorean theorem? Don't I know this side? I know this side, and we're looking, well, I'll call this y. So couldn't we do the Pythagorean theorem now because we know two of the three sides? As long as we execute that correctly, you've been doing the Pythagorean theorem since junior high, that might be your best bet right now. However, Vicky found that other side initially. How did you set it up, Vicky? What did you do? So she set up the sine of 39 degrees. So she used this angle up here. And isn't the sine, again, opposite over hypotenuse? So she did the opposite side over the hypotenuse of 24. That also would have worked to find that other side. If we do it this way, you're going to multiply by 24. And then throw this into your calculator. Should give you the same thing you would have gotten if you had done the Pythagorean theorem. Okay, what did it give you, Vicky? Good. Was there no second decimal?
No.
All right. If you do the Pythagorean theorem, it should also give you this 15.1. All right. Okay, any questions on that? Following all this? All right, number 2 then. Measure of angle E is easy. All right, we know 2 of the 3 angles. We know this is 90. We know this is 16. All the angles have to add up to be 180. So what is that, 74? 74 degrees. So we know angle E is 74 degrees. All right, let's do this just so we can call these variables. Let's say EG is X. So let's call this your X, and we'll say FG is our Y. We can't do the Pythagorean theorem yet because we only know one of the 3 sides. So we're only left with SOHCAHTOA, sine, cosine, or tangent. Pick whichever angle you want. Let me do this one together. Just make sure we get another one done before we leave here. I'm going to pick 16 degrees. I have to use the 8. So those are the 2 of the 3 pieces of information that I want to know. I could use either one now to figure out Y or X. So let's say I want to figure out Y. That's the one that I want, and this is my reference angle. In relationship to 16, the 8 is the what? Adjacent, opposite, or the hypotenuse? So 8 is what compared to the 16? Is it adjacent? Is it the hypotenuse, or is it the opposite side?
Isn't that the opposite?
Good. The opposites at home and in here, everybody's saying that's the opposite. So we know this is the opposite side of 16. And if I want Y, is Y the adjacent side or the hypotenuse? Adjacent. So think SOHCAHTOA. Which of those, sine, cosine, or tangent, deals with the opposite side and the adjacent side? The tangent. So we're going to say that the tangent of 16 is equal to the opposite side, which we know to be 8, over the adjacent side, which we are calling Y. Don't solve that just yet, because I want to make sure we see one more of these before the bell is going to ring. Let's say I wanted to solve for X. So now let's clear these out a little bit. So now I'm going to solve one for X, and I'm going to use this 16. So if this is 16, do we agree then that this still has to be the opposite side of 16? So this is still our opposite. Come on, you. What is X? X is the what side? Adjacent, opposite, or the hypotenuse? Hypotenuse, right? So if I wanted to do x right away for angle 16, which one deals with the opposite and the hypotenuse from our SOHCAHTOA stuff? Opposite, hypotenuse is which one? Sine. So we could have done the sine of angle 16 is the opposite side of 8 over the adjacent, or the hypotenuse, which was x. Those are our two equations. Now let's remember, see if we remember how to solve this. We don't want the y in our denominator, so we're going to multiply that out of there, which means you're going to multiply the y to the other side. So then we have y times the tangent of 16 equals 8. And then since this is a product, the way we undo products is through division. So what that does is gets rid of this. So our answer then, when we divide the other side by the tangent of 16, should be whatever this would give you. All right, so throw that in for me. I'll use my calculator. So 8, and then you're dividing by the tangent of 16. And this is what, y? Y is FG. All right, what's that give us?
I got 27.
Seems reasonable. Anybody else getting that? 27. And what's our two decimals? 8, 9. Okay. Now you could do the Pythagorean theorem now, right? Like this is 27.89. So if you want to do the Pythagorean theorem, we now have two of the three sides. It's the 8. It's the 27.9. We can get the hypotenuse. But we also have this equation right here. So multiply this by x. So we get x times the sine of 16 equals 8, as those would cancel. Divide the sine of 16 into the other side. This will also give you that third sine. But again, once we have the two sides, you can do the Pythagorean theorem if you just like that better. All right, what is this? Get 40 something? I didn't key it up, so I was going to use the calculator. Computer, I'm scared to pull that thing up right now. Anybody give this confidently? Should be 30s or 40s, something along those lines. 29? Is it that small? Okay. And then what are some decimals here? Any? All right, we're all getting 29.02 then? Okay. All right. We didn't do any second signs again. I think you're going to be spared. Yeah, we'll spare you homework tonight. So bring this tomorrow. We'll finish off 3 and 4. I want to make sure these are going to be the angles with the whole second inverse function, which is the new part for the day, one of the new things. So just bring this tomorrow. We'll finish it off. We'll spare you the homework. We'll finish that tomorrow and give you some homework tomorrow night. Okay? So if you're at home, take off. We'll see you guys. Have a good day.